Understanding the situation is one thing, but it's the transition of that understanding into informed decisions that will truly make a difference. As we step into this next phase, you'll be shaping our raw data into meaningful views, providing essential information to decision makers. This will enable us to discern the materials we need, plan our budgets, and identify the areas requiring immediate attention. We're not just analyzing data, we're making it speak in a language that everyone involved in this mission can understand and act upon. Lastly, we'll be creating job lists for our engineers. Their expertise will be invaluable in tackling the challenges we face, but they can only do their job effectively when they have clear data-driven directions. Remember, each step you take in this process contributes to a larger goal, the transformation of Maji Ndogo. Your diligence and dedication is instrumental in shaping the brighter future of our community. Thank you for being a part of this journey. All the best, Aziza. Niendelee.
Yes, you can continue.
Let me unmute, then I go back to the screen. Yeah.
Mm-hmm.
Hey, how have you been? I am moving to another project soon, so this might be the last time we work together for a while. I thought you would appreciate this. Corrupt officials arrested, blah, blah, blah. It's really good to see justice taking the front seat. Maji Ndogo is changing, and I think it's because President Naledi gets it. Our journey is at a tipping point. She is serious about using data and having no room for corruption, and that gives me hope. We still have a bit of analysis to wrap up, and then we need to create a table to track our progress. Let's start with the last bit of analysis. So I used to be tempted to put all of the columns from the table in one place /table and then analyze data, but on a data set this size, we're going to run into performance issues. So we should rather spend a minute thinking about the questions we still have and create queries to answer them. Specifically, doing this means that we will only use the data we need to answer our question. Let's summarize the data we need and where to find it. Point 1, all of the information about the location of our water source is in the location table, specifically the town and province of that water source. Point 2, water source has the type of source and the number of people served by each source. Point 3, visits has queue information and connects source ID to location ID. There were multiple visits to sites, so we need to be careful to include duplicate data. Visit count greater than 1. Point 4, well pollution has information about the quality of water from only wells, so we need to keep that in mind when we join this table. Previously, we couldn't link provinces and towns to the type of water sources, the number of people served by those sources, queue times, or pollution data, but we can now. So what type of relationships can we look at? The things that spring to mind for me, number 1, are there any specific provinces or towns where some sources are more abundant? Number 2, we identified that tap in home broken taps are easy wins. Are there any towns where this is a particular problem? To answer question 1, we will need province name and town name from the location table. We also need to know the type of water source and the number of people served from the water source table. The problem is that the location uses location ID while water source only has source ID. So we won't be able to join these tables directly. But the visits table maps location ID and source ID. So if we use visits as the table we query from, we can join location where location ID matches and water source where the source ID matches. Before we can analyze, we need to assemble data into a table first. It's quite complex, but once we're done, the analysis is much simpler. Start by joining location to visits.
Okay, I think we should start with that. So how do we go about it?
Please.
Anyone? How do we join the location to visit?
I think before you begin to bring everyone on board, it could be a good idea to explain the slides so that sometimes when some people read, you can't catch up well. But when you try to give an overview of what is there, people will understand better before you even begin. Will it work?
Yes. Maybe you can continue to explain what exactly we are starting with or what we are supposed to do.
Actually, there's a lot of rain on my end. If someone else can help us, it will be better. Just to help us understand the slides. Like slide 1, they are talking about what, slide 2, and then try to connect everyone so that when you go to the MCQ, you know exactly what they are talking about here. Or that's always my approach. I don't know if people understands, but for me, I'm not that good in just reading and understanding unless I try to analyze to understand it better in details. On my end, I can't do that because there's a lot of time here.
Okay. Based on this first table, this first slide that is showing on the screen, they are telling us that usually the person usually brings all the tables in all the tables, all the columns in all the tables as one in one place. But based on the size of this data, it will be complex to do so. So it's easier if one begins to analyze one at a time. So the summary suggests the data that we'll be needing and where we'll find it. For instance, it tells us that all the information about location of water source is in the location table, specifically the town and the province. So where the water source is, you can find the town where the water source is and the province in the location table. And since the water source has types of sources and number of people served, the people that are being served by that particular water source, we can find the information in the water source table. The visit table has the columns that can connect source ID to location ID, and also has the information when the number of sites that were visited. So we need to take note that some sites can be visited more than once. So we would also have to put that in mind. And the well pollution has information about the quality of water from only wells. So any quality of water we are finding in the wells column is for wells alone. So we can move up to the next slide, please. So to start, they are suggesting that from what we've learned so far, the two things that comes to the analyst's mind are: one, are there any specific province or town where some water sources are more abundant? So since we know there are different water sources, we know there's well, there are taps, there are other. Are there any particular towns or provinces where one is more abundant than the other? And the second thing that comes to mind is, are there any towns where broken taps is a particular problem? So we want to try and answer these two questions. But for the first question, to determine the provinces and the town where we have one water source more abundant than the other, we will need to extract some information from those tables. Of course, we want to know where the province are, so we need province name. Of course, we want to know where the towns are, so we need towns name. And we've been informed that town name and province name, you can find it in the location table. We are also interested in the water source because that's what we are trying to see, the one that is more abundant in a particular location. And of course, we can find that in the water source table and the volume of people served as well. So we've been asked that we should start by joining the location to the visit table. Remember, we can't start by using location to this water source table because there is no connection. So, but we remember when we're reading it that the visit table has a connection to both location and source. So we'll start by joining location to visit table. And I think that's where we'll start from now.
Okay, thank you so much, Leroy. That was a good explanation. So, how do we start?
We can start by selecting the columns in location table and then join on the common column between visit and location table. So we can start by looking back at the column that is common in both visit and location table, which I think was highlighted in those 3 points, or we can just view it directly here by just selecting star and running to it.
So we have the visit table. I hope everyone can see.
Yes, we
So
can.
we have location ID and ID. And then on the location, we have location ID. So we are joining these two with the location ID, right?
Can we see the visit table, please?
Here it is.
Okay, this is the visit table. Okay.
Yeah.
Okay, so both of them have location ID. So we can join on location ID.
Yes. Okay. This one also has location.
Okay.
So we join with location. We are only putting location, or what other columns are we putting?
Can we just look at the location table again? Sorry. So we are putting location, we are putting province name, town name.
Okay. Province name and town name.
You also have the visit count.
Yes, and visit count from the visit table.
Visit count.
Visit count from the visit table.
Okay.
But you have to identify the table for the visit count. You have to identify
Yeah.
the table. Mm.
Then join. Is that correct?
No, we need to identify the table the visit count is coming from.
Yeah, that's what
So-
I've included. Join visits.
No, I mean the visit count column. It
Or
has to be like,
are we giving it an alias, or we just use the whole
I think we should
visit?
use alias V as V. Exactly. As L. Yes. L dot.
Like that.
And then
Yes.
also there at the top, you need to say use the database name for it to work.
I think it's highlighted, or
Oh, okay, it's selected.
if it's
I
Okay,
think since we have
it's
already run
selected.
the database, it would
yeah.
It's
work.
selected. Yeah. Okay, thank you.
So we are joining it with location.
Location ID.
Okay, like that. Is that okay?
Yes.
Location as yes.
So let me just comment what we are doing.
We are trying to answer number one question by joining location to visit table.
Okay. So we can go back to the slides and continue. Should have the following columns. Let's just check. I think we do. Yeah. So now we can join the water source table on the key shared between water source and visit. Let me just take this. So how do we go about this? We are now
So
joining.
with the water source table. So I think we should just check. I think the water source table and the visit table share source ID. So
Yeah.
okay, so we can just put join on water source. Join water source.
Any alias?
W. Yes, the W on next line on v dot source ID equal to w dot source ID ws dot source ID.
That's okay.
Yes, but we need to include the extra column. What columns are available in source ID in the water source?
We have
Type of water source and number of people served.
Okay, so we include that
So
WS
WS,
dot yes, so WS dot type of water source and yes.
Okay,
Thank you, Eve. Thank you.
that's okay. So we can run this. Let's check and see. Yeah, I think it's the same.
yes, it is.
Okay. Uh-huh.
So it says note that there are rows where the visit count is greater than 1. These are the sites our surveyors collected additional information for, but they happened at the same source location. For example, add this to your query where visits dot location ID is equal to. So I think we just copy that. They want us to see that some sites were visited more than once, but they carry the same location ID.
Yeah.
Okay, so we can see visit count, the
Yeah.
number of times.
So, Leroy, may you just explain what's happening here so that people
Okay,
can understand?
so what's happening is that this particular location ID, the surveyors visited there a number of times for various reasons to gather additional information. So what they are saying is that for every visit, they had the visit count increases, but the information they gathered, that's why it's possible for you to have one location ID since it's the same place, but frequent visits to collect additional information. So that's why we are able to have multiple um, same location ID, and we see the visit count is counting as the visit for additional information that they acquired there. So that's just what we are checking.
Okay. So, yeah, this is what we got. Someone to continue reading?
There you can. Okay,
Yeah.
please go on. Please go on, Faith. Sorry.
Okay. Wait, I'm starting from there you can see or where?
Yeah.
Exactly.
Okay. There you can see what I mean. For one location, there are multiple records for the same location. If we aggregate, we will include these rows so that our results will be incorrect. So to fix this, we can just select rows where visits dot visit count equals 1. Remove where visits location ID equals that code. Add the visits dot visit count. Okay, visits from visit count equals 1 as a filter. Okay, now that we have verified, okay, should we stop there so we can do this? Or I continue reading?
I think we
Okay,
can do
I think we should
that.
do it first.
So we've been told to remove this and do what?
Add visit count as equal to 1 as the filter.
Like that. So can someone explain, please, so that people can understand what is happening? Why we are adding this clause?
Actually, I feel like we came across this last time as well, where we had people going to multiple locations. So we were supposed to filter where visit count is equals to 1 to find out just where they went to just one location, because I think that's the idea. Oh, the other one was to reduce the visit count for locations. Just a second.
Going to one location or going once to a particular location?
Going once to a particular location, once, because there are others where there are multiple visits.
Okay.
That's true. So I think why we put where visit count is equal to 1 is to ensure that we have one location ID per visit, rather than the columns we had, and we had multiple location ID for a single place, and we had multiple visits. So it's possible that the visit count reaches 10 for one location ID, and another one is just 2 visits. So we have that location ID visited twice. So if we try to aggregate, it will pick all those columns and aggregate it, and that's what they're trying to, avoid. So they are trying to tell us that, okay, one location ID, one visit, one location, and the best way to do that is to use a visit count of 1, because that's the minimum number of visits that is possible for a site.
Okay. So Lira, will it exclude those locations that were visited more than once?
Yes, because they've already been visited once, so that column will be captured already.
Okay.
So they are just trying to ensure that we have unique location ID for a visit. So it's just like saying, knowing how many locations that we visited. People putting exactly one location per visit, so you can easily count how many locations were visited with this.
Location ID rows. Is that correct?
Yes, exactly.
Okay. Okay, so now that we verified that the table is joined correctly, we can remove the location ID and visit count columns. So I think we should do that now before we continue. What are we removing again?
Location ID and visit counts.
And visit count.
So I can remove this and visit counts. Okay.
So I feel that by doing that, by putting this where visit count is equal to what, it also helps with the join, particularly because the source ID that we joined with will not have that count of number of visits. So it will have one source ID for one location, whereas the other table has like uses location ID has multiple of the same place. So there'll be no values in that source ID column. So by doing this now, we've eliminated all that as well.
Okay. So add the location type column from location and time in queue from visit to our result set. So we are adding, let me go back again. It's here. We're adding location type.
Time and time in queue. And time in queue. So remember that location type is from location table. So we need to include L dot location type.
Okay. So let's continue so that you can get more information. I think we have the same table. Yeah. Sorry. Okay. Someone to read?
Okay, last one. Now we need to grab the results from the well pollution table. This one is a bit trickier. The well pollution table contained only data for well. If we just use join, we will do an inner join so that only records that are in well pollution and visits will be joined. We have to use a left join to join the results from the well pollution table for well sources and will be null for all of the rest. Play around with the different join operations to make sure you understand why we used left join.
Okay. Who will take us through? Who will take us through this and what we're supposed to do? How are we going to join the well population table? And also, why are we using left join as we've been told? Anyone? Anyone who can take us through, please? Or I go back to the slides, we read again. Anyone? Should we join with the source ID? I hope I'm not doing my own things. Is that correct? Am I audible? Can anyone hear me or?
Yes, you are.
Yes, you are.
Okay. Is this correct? Should I run it or? And why are we doing this? Or rather, what are we trying to get? What information are we trying to get that we're not using the join only or inner join? Anyone? I don't know if that's correct. Is this correct? Before we continue, or we should continue with the slides and see.
Jolene, yes, you can speak.
I'm seeing the code in the slide, so I think you're correct.
We use the left join.
Can you check the slides where the code is? There's a code been given.
Can someone explain this? Please. Because we are changing everything. Actually,
We are using the okay.
sorry?
The left join, the inner join is it helps us get only records that are in the well pollution as well as the visits. Yeah, so we don't want to duplicate them. That's why hiyo kitu left join.
So getting information that is only on the visits
Yeah, it
table
will be,
and
yeah,
well
and
population.
also the sources, the well sources.
So you're explaining this part.
The code is the code
This
you've
part.
joined. Since we are summarizing everything, like we are assembling everything from all the tables, like the visits, well pollution, water source and location. But now it has to be hizo zingine ni inner join, but the left join for the well pollution is it is left join so that we don't have like we have only records that are in the well pollution and the visits.
And then inner join.
Yeah, we are merging the location ID. It's the one that is common on both the location and visits. And then the water source, it is the source ID from the visits and water source. Now all the tables will be merged, but they're specifying we still need the visit count to be 1 per location.
Okay. Has everyone understood why we are doing this? Okay. I think we can continue.
I think that there's someone who is asking that you repeat again in the chat.
Who was explaining? Or anyone else who can explain?
Okay, I can try. Can I? I see
Yes.
there's a hand. I don't know if she wants to try. However, let me try to talk about that part because this lets you understand. This is where you want to define where you want to display actually the columns that you want to display in the output. So I think that there's not much information here. Now on the left join, that part, the first part on the left join, here you are trying to retrieve all the information from the well pollution, and then from the visits you want to retrieve information on the source ID, all the information from the well pollution. But now on the source ID you want to retrieve only information which are which are available in both sides, either in the source ID or at the visit. So it will look for the particular or a unique, the identical or duplicates source ID, then it will add it. But for well pollution, it will retrieve everything. So basically, the left join, this one will pull all the records or all the information on the well pollution. But now in the other table, it will pull only the information which are identical. And then now the inner join, with the inner join here in the location and the visits. So basically here it will look for identical location ID. Then when it finds, basically it will merge only the unique, or the similar IDs. It will merge it will return only the similar ID on the location. In the location ID in the location, and then the visits ID in the. Wait, let me try to repeat. Let me first of all begin even with the left. Then so basically in the first one, in the left join, basically in the left join it means that it will return all the IDs, source ID in the well pollution, but in the source ID in the visits, it will return only the IDs which are identical in both sides, which they resemble. Basically in the well pollution in the visits. And with the inner join, now the second part, it will look for IDs which are identical in both sides, in the location and in the visits. Then it will match them to be one. The same applies in the water source. The other inner join here, it will retrieve the information or the source ID which are identical in the water source and at the visits ID. And then after it has done all these joins, it will now we use now the where filter so that it may return the information where the visit count is equal to 1. So basically this is what it does.
Okay.
In summary, the inner join will merge identical. It will return only identical IDs, and then at the left join, this one return all the records from the well pollution, but in the source ID, in the visits, it will return only the identical, the IDs which are identical in both sides. So it will return only those, and it will leave the rest which are not identical, which are not found in the well pollution table.
Okay.
Or you guys, you can see that we have a source ID on the water source table and the visits table.
and the well pollution table. So we had already merged the visits table and the water source. Now it becomes trickier to merge the well pollution table because we have a common column in all the three. But now they are using the left join so that we can have only the data that is in there, both visits and well pollution, only records that are in the well pollution and visits. That's why we have an inner join there. We can't go ukiachilia unaweza pata you are retrieving the source ID from the water source. You get now?
Yes.
Like we have a source ID in 3 tables, right?
Yes.
But we had already merged the visits and the water source. We had already made the table 1, but now we just want to add the data that is in the well pollution table. So we use a left join so that it collects only the one that is. Yes, Leroy.
No, I'm listening to you actually.
The left join is used. We are using left join on that only part for the well pollution, so that we get the source ID from the well that is only in the well pollution and visits table after joining.
Okay, sorry, let me just ask a question. Which table is going to be at the left side from what you're explaining? Is it the 3 tables you've joined together or the well pollution table?
Here there'll be all the tables. Like we are combining the analysis.
Okay, so you're saying that.
Can I help with the explanation?
Yes.
Okay, please.
The way I understand it is for the join. I'll start with the join. The join, it brings everything that is in the tables. Like if you are joining the visits count, visits and the water source, the join will bring everything, even the duplicates. The inner join will look for the columns. If the type of water source is in the visits count and it's also in the let's say the water source, it will bring everything, but it will eliminate the duplicates for the inner join. You see, the join will return everything plus the duplicates, but the inner join will remove all the duplicates and return the distinct data. So for the left join, it will check for the rows. If could you please for the well pollution, it will check for the rows. If the row for well pollution has the source ID, it's the source ID, right? The source ID is the same as the one in the visits count. It will return that specific. If there's no match, it will return a null value. This is because it checks the rows and returns the columns. Have you understood what I'm trying to explain?
Yes, I personally understand. I don't know if the others have understood. Anyone else who has a question on this? Okay, so we can move on. Okay. So we've already.
Can you hear me, please?
Yes.
Can you hear me, please?
Yes. Yes, we can hear you, Leroy.
I was saying that. Okay, so I was saying that the join, the SQL table understands that when you use the join, it means inner join by default.
Sorry? Leroy, you were saying something. Have we lost Leroy?
I think Leroy was just saying that inner join is like join by default in SQL, right? It will bring everything. But we had already joined the visit table here. And whatever we're trying to merge from the well pollution table is in the visit table, is the source ID. So we use left join so that it can collect only records that are in the well pollution and visits. Because there are other records in the visits that are in the water source, location table. You get?
Yeah. Okay. So we can continue.
Yes.
Okay. Who was reading? Or anyone else to read for us? Someone to read for us, please.
Sorry, where are we? Mefikia.
Up.
Oh, okay. Let me start. This view creates a table that pulls all of the important information from different tables into one. You may notice our query is starting to slow down because it involves a lot of steps and runs on 60,000 rows of data. The last analysis, we are building another pivot table. This time, we want to break down our data into province or towns and source types. If we understand where the problem are and what we need to improve at those locations, we can make an informed decision on where to send our repair teams. We did most of this before, so I'll give you the queries I used, explain them a bit, and then we'll look at the results. The queries I'm sharing with you today are not formatted well because I am trying to fit them to my chat messages. But make sure you add comments and document your code well so you can use it again. So the code has been provided there.
Okay. Can someone explain to us what we are trying to do first before we go to the code? What are we supposed to do
Have
here?
you created the table already? The view?
Not yet. I don't know which from.
Yeah. Create it first, the view, so that because this one now is dependent on the view.
Okay, so just try and explain what we are trying to do first.
On the upper slide first, create a view for that CTE, or I don't know what it's called.
Please guide us.
There's a code in the
After
before that, yeah, there. Create
This
the view
one?
path. Yes, because we'll be using one table there, I think.
I think we've done the didn't I? Ah. Did we read this? I don't think
I don't think we read it.
This
So
one,
I think we should
yeah.
go back.
So after doing the left and inner join, we were supposed to start from here. Sorry. So we skipped this bit. Can someone read for us from here?
So this table contains the data we need for this analysis. Now, we want to analyze the data in the result set. We can either create a CTE and then query it, or in my case, I'll make a view so it will be easier to share with you. I'll call it the combined analysis table.
Okay. So basically, we are trying to make a permanent table, which is the code that we had. The code that we had up there, right? Is that correct?
Yes.
Okay. Let me
So,
yes.
can I just ask a question of where we have passed, to just see if we are able to get it?
Sorry?
I said I just want to ask a question to ensure that we are all following. Would that be okay? Can you hear me?
You are saying?
I said I just want to ask a question.
Okay. Yeah, you can ask.
Okay. It's actually what you just said now. Why will it have been wrong for us to use a join or an inner join to combine the well table with the other tables we had combined earlier? Who can just say why it would have just been wrong? What would have made it wrong?
To use join instead of inner join.
No, join is the same as inner join by SQL default. Why would it have been wrong for us to use join instead of left join? What would have happened? I just want to bring out a point.
I think based on the explanations that were given earlier, I think when we use join, it combines, it brings up everything from both the tables. But if we use a left join, it brings specifically the information that is on the well population and the what is on visit table that is on well population. I don't know if I'm saying it correctly.
Okay, let me make it easy so that we'll all get it. If we had used the join function, what will happen is that it will look for the source ID on only wells and combine it with the source ID that we have in the combined table that has only that source ID and now join two of them together. So we would actually have a table that contains results for only wells. But by using the left join, we are telling it that the left table, which is the combined table we have, bring out all the source ID, right? Left join with the wells table, meaning that whatever source ID you find in the wells, that is also in the combined table, put it there. Where you don't find information on the source ID, you found in the combined table, just fill in more. So you have a bigger table that has the whole combined table result with wells. Then where there is no result for wells, you just fix in more. I don't know, maybe that makes sense.
I think that's wonderful explanation.
Yes, I think everyone has understood that point. An error. So we've created a view. Yeah, it's here. Let's just try and see. So we have the table here. So we can continue. So we were here. Can anyone explain what exactly is needed here?
Okay, I don't know if anybody can hear me.
Yes.
Okay, so what Chidi is saying here is that it's kind of building a pivot table like we did when we're doing our spreadsheet, right? But this time we are saying the columns we are interested in are the province table, the province, town, and source types. Of course, we are looking at the aggregated functions, kind of, when we are dealing with pivot tables generally. So it says when we break them down into that province, towns, and source type, then we can now say, okay, this province has maybe a lot of broken taps. This town has a lot of broken taps, so they can know exactly where to send the repair teams. So obviously, it's going to share the code with us, but we will need to arrange the code properly because there's no formatting it well. So I think we should just have a look at the code as well.
Okay. This is the code.
So as you can see the code, you will see that is we aggregated in the code. Remember I mentioned that for pivot tables, we deal with aggregated functions. So that thing we did in spreadsheets, when we're doing Google Sheets, where we would try and do pivot table that, mention columns and it give us the aggregated functions. That's what we're trying to do here, but this time with code. So, like I mentioned, we are interested. He's building. What is he doing? Okay, so he's building a CTE, province. So he's gaining province name, uh, the people served, and yes, so he's gaining province name, people served, and also, is there any other thing he's doing? Province total. Okay, province name, combined analysis table. Okay, I think the combined analysis table city is the one we had created earlier. So we is adding that one to this one. So we are able to get basically those three columns, the aggregated function using those three columns is what we are doing using code. That's just basically what we are doing. Using the group by the province name, you know, to calculate the totals of the type of water source, the type of water source, as well as their location and the province name and province town. So basically, that's what they are doing with this long code. But if we run the code, we'll be able to appreciate it better.
So basically, this query is trying to show us for each province the number of people served with each type of water source, right?
Exactly.
Okay. So has everyone understood the code? Or can someone explain further why we are using this query, or how we've come about the query? I think someone should explain, because I'm seeing there are new concepts like case, when. Anyone? What does case statements do? Maybe we can start from there.
I can try, though I don't know if it.
Okay.
Okay, you can go ahead kindly.
Okay, I just want to mention what the case function is for. The case function is used to group, so it's like saying, when we are using the case function, we are trying to say if we are trying to say if, for instance, we have a table that contains, let me just use a simple table, a table that contains maybe fruits like apple, banana, orange, mango, and grapes. If we have that table and we have the prices of these fruits, if we say, if we write an SQL code like select fruits, price, those are the two columns, and we now say case. When price is less than 1, then low price. When price is greater than 1, they say, and price, we now put, maybe if price is greater than 1 and price is less than 2, medium price. When price is greater than 2, 3, high price. So the result will generate the product, which is the fruits we mentioned, their prices. Then to now create a category, because after the end of the case statement, we usually add an alias, you know, usually add an alias. And let's say we name the alias price category. Then it will, the price category will contain those things I mentioned, based on the price category. So that's what it will create, like a table that visualizes that classification based on it. So if I try and look at this one, this city that was created, so it's saying case when source type is equal to river, then, okay, what did it say? It says case when source type equals river. Let me see if I can zoom in to see that. Okay, so it says case when source type equals river, then people served, else 0. Is that 0, please? I'm using my phone, so it's difficult.
Yes.
Then end, then multiply by 100 divided by as river. Okay, so basically there is just doing basic mathematics with that case. That when that column, when the source type column is river, when the cost source type column is river, it should then do that calculation to label it river, to label it as river. If the source type is river, then if the people served, then people served L0, and it should multiply by 100 divided by total people served as river. So it's doing this math calculation, then calling it river. Then does the other calculation too, calls it the other type of water source, shared tap, So I think it's, yes, it's doing this math, calling it different types of the water sources, on a special column. And that's basically what it's doing. But if somebody has, a better and clearer way to say it, that'll be fine as well.
Okay, I can try maybe to add on what you've said. You can go there. Now, the case clause or a command it is just like the if condition. It's just like the if condition. Like when something meets a certain condition, it should return something. Otherwise, it should return something else. Now, in this case, for instance, when the source type, this is the column source type, when it has river in it, a string, then it should return the number of people served. Otherwise, it should return 0. Now, all of the results there, it will divide by it will multiply by 100. What is that calculation? Multiply, I think is asterisk. 100 divided by pt dot total people served. 100 over total people served times the result that will be outputted there. If it's 0, it will essentially mean that all the results will be, the output will be 0. And then the alias here is just used to define the column name. It's just used to define the column name, just like what we were used to. The alias just to define a temporary table. So basically with these commands, like you are creating a table from a row. Like we had a column, not a row, it's a column. Like you had a column that had several categories, like for example rivers, shared tabs. But now when it meets certain condition, then it will create another column. For instance, for river, when another table meets a certain condition, then it will create another column, maybe shared tabs and so forth. So essentially the case statement is just like the if condition. So when something meets a certain condition, then it will give a certain result. When it doesn't meet, then you can as well use the else statement. But if you don't specify, I think it can return null. But in most cases, you can specify the else if it doesn't meet a certain condition. So basically, that's what I understood about the case statement.
Okay, I think it's clear. Has everyone understood? So I have a question. So basically this CTE is giving us the total people served so that we can use it to calculate now the percentages per type of water source. Right?
I think so, unless someone
Because
else.
I'm seeing this here is basically what we've gotten here.
I think that is it. I think that's right.
Okay. Okay. I think it's clear. So we can continue. I don't know if I've added a comment here.
Oh yes, I think you are very correct. So it's getting the percentage of the water. How should I put this? The water source percentage of the total people served by various water sources. So categories. So at the end of the day, if you sum up all the water sources, it should give us 100. You are very correct.
So here I can write percentage of people served per type of water source. Is that correct?
Yes, ma'am.
Okay. So we can continue. Someone to read for us?
Okay, I should read from the province totals.
Yes.
So province underscore totals is a CTE that calculates the sum of all the people surveyed grouped by province. If you replace the query above with this one, the select from the province underscore totals, you should get a table of province names and summed up populations for each province. The main query selects the province name, and then, like we did last time, we create a bunch of columns for each type of water source with case statements, sum each of them together and calculate percentages. We join the province underscore tables to our combined analysis table so that the correct value for each province PT total population serve value is used. Finally, we group by province name to get the provincial percentages.
I think basically here they're explaining now the code that we've queried above. So I think it's clear now to everyone that we are using the case statements as it was explained earlier. Then I think there was a join here. Yeah, so we join the province total table and the combined analysis table so that the correct value for each province total people served value is used. Then they are grouped by province name to get the provincial percentages. Okay. Someone to read for us?
Okay, run the query and see if you can spot any of the following patterns. Look at the river column. Sokoto has the largest number of people drinking river water. We should send our drilling equipment to Sokoto first so people can drink safe filtered water from a well. The majority of water from
Just
Manzi.
Felix, we can go to the table and confirm this.
Okay.
If Sokoto has the largest population of river. Yeah, so it's true. Continue.
The majority of water from Amanzi comes from taps, but half of these home taps don't work because the infrastructure is broken. We need to send an engineering team to look at the infrastructure in Amanzi first. Fixing a large pump, treatment plant, or reservoir means that thousands of people will have running water. This means they will also not have to queue for water, so we improve two things at once. Spot any other interesting patterns.
Okay, you can go and seek first on Manzi. Yeah. So we can see the tap in home blocking is a lot in Amanzi. Any other patterns that we are seeing?
Please, can you explain what we are trying to do now, please?
Basically, we are trying to see the patterns here from the tables that we've gotten per province. So, like the first pattern that we were given in the slides, it's saying that Sokoto province, they mostly use the river. So that means that we need to fix that. As you can see, they're saying that we should send our drilling equipment to Sokoto first so people can drink safe filtered water from a well. I think river is the worst when it comes to this water types. People who are using water from the river are more prone to having contaminated water. So the first pattern is we can see Sokoto has most people using the river, and then they're saying that Amanzi, in Amanzi province, we have a lot of tapping homes which are broken. So we also need to look into that. We need to prioritize that. So, and they're asking us if we can see any other patterns that we can prioritize. So basically, that's what they are saying. So can we see any other trends, or we can move on?
Is there a way we can find the maximum function of each of these columns? That will just help us. You understand what I mean?
Yeah, to get a maximum of each water source.
Yes, each water source. So that will just help us.
But I think there are not so many, so we can just have a look. There are not so many. So like
yes.
river, we have 21. And then for shared taps, we have a Katsi with most people served with shared taps. And then we have Amanzi. Most people have tap in home. Then Amanzi still tap in home but broken. And then we have for well Hawassa.
So we can say that, for instance, Amanzi, basically they have maybe just 4 taps that are functioning. Because even though they have about 28 tapping homes, 24 are broken.
Yeah.
So it's only 4 that is functioning. For places that have like Akatsi, they have a whole number of wells. They have the same number of taps as Amanzi that are functioning, which is 4. And they mostly, aside wells, they also use shared taps a lot. So that 4 tap that is functioning probably, okay, that's not tapping home. Those ones are shared taps. So they have a lot of shared taps in the city. And so basically we see that there are a lot of broken taps in homes. Even though they are available, they are really, most of the taps in the homes are bad. Because if you look generally, you see that the highest, for instance, Hawassa has 15 taps in home and 15 are broken. So the highest number of functioning taps, which is Sokoto, is 6. So as the pattern I see is that even though they have a lot of tap in homes, most of it are broken. So most of it needs repair based on this size of table, this particular table. That's my observation.
Yeah, that's a very good observation. Thank you. Any other observation, or we can continue? Okay. So, someone to read.
I made another graph to help us see the patterns. So the graph, you can see the graph there with Amanzi. Is it Amanzi, Akatai? Yeah, until Sokoto down there. Let's aggregate the data per town. You might think this is simple, but one little town makes this hard. Recall that there are two towns in Maji, Ndogo, called Harare. One is in Akatsi and one is in Kilimani. Amina is another example. So when we just aggregate by town, SQL doesn't distinguish between the different Harares, so it combines their results. To get around that, we have to group by province first, then by town, so that the duplicate towns are distinct because they are different towns. So we can use the query that has been provided in that page.
Okay. So maybe we can compare this and what we had earlier and see what they've added.
Please let's not forget to comment on the code so that we will not be
Yeah.
lost.
What have I done now? So here we are trying to, what exactly are we doing? Group by province. So basically it's the same table, it's the same query, I mean, but I think they've added something when grouping. So I think this is where they've changed it. Is this clear, or you see here we just grouped by province name, but here we've added town name so that we can be specific that Harare is for a particular province, or is it town? Yeah. So you can see it has separated. There's a Harare in Akatsi and there's a Harare in Kilimani. Is that clear? And did I comment here? To everyone? Okay. Can continue reading.
Here, the CTE calculates town totals, which returns 3 columns: the province name, town name, total peoples served. In the main query, we select the province name and the town name, and then calculate the percentage of people using each source type using the case statements. Then we join the town totals contained the town totals to combined analysis table, but this time the town names are not unique, so we have to join town totals, but we check that the both province name and town name matches the value in combined analysis table. Then we group it by province name, then town name. This query can take a while to calculate, so hopefully you start to see how a query can quickly become slow as it becomes more complex. This query can take a while to calculate, so hopefully you start to see how a query can quickly become slow as it becomes more complex. Before we jump into the data, let's store it as a temporary table first, so it's quicker to access. The temporary tables in SQL are a nice way to store the results of a complex query. We run the query once, and the results are stored as a table. The catch: if you close the database connection, it deletes the table, so you have to run it again each time you start working in MySQL. The benefit is that we can use the table to do more calculations without running the whole query each time. To add it, and add this to the start of your query.
Okay. I think I should remove this. Where do we find the temporary table? Where is it usually stored?
I think they say that it is stored in the cache. It's not in that views. This is just when this MySQL workbench is opened, but when you not MySQL when that database is opened, but when it's closed, then you have to run it again. So it's not stored as a view. A view is stored permanently, but now this temporary, it is stored only when this one is active, the database is active.
I hope I've explained it well. Is that explanation okay?
Yes, it's okay.
Okay. So how can we view the table? Where can we get it to see how it looks like? Is it possible?
Can you try to do select all from that a temporary table? What was the name?
It was
You can
called
just
what?
copy. You can just copy paste.
Yeah. What am I doing? So it's the same. Okay. Someone can continue. And if you guys are tired, you can tell me to stop.
So let's let's order the results set by each column. If we order the river the river decreasing, or it confirms that we saw on a provincial level people are drinking river water in Sokoto. But look at the tap in home percentage in Sokoto too. Some of our citizens are forced to drink unsafe water from a river, while a lot of people have running water in their homes in Sokoto. Large disparities in water access like this often show that the wealth distribution in Sokoto is very unequal. We should mention this in our report. We should also send our drilling teams to Sokoto first to drill some wells for the people who are drinking river water, especially the rural parts and the city of Bahari. Next, sort the data by province name. Next, look at the data for Amina in Amanzi. Here, only 3% of Amina's citizens have access to running tap water in their homes. More than half of the people in Amina have taps installed in their homes, but they are not working. We should send our teams to go and fix the infrastructure in Amina first. Fixing taps in people's homes means those people don't have to queue for water anymore. So the queue in Amina will also get shorter. There are still many gems hidden in this table. For example, which town has the highest ratio of people who have taps but have no running water? Running this, so the query have been provided that you can run to address what has been explained up there. So maybe I can continue reading. We can see that Amina has infrastructure installed, but almost none of it is working. And only the capital city, Dahabu's water infrastructure works. Strangely enough, all of the politicians of the past government lived in Dahabu. So they made sure they had water. The point is, look how simple our query is now. It looks like we are back at the beginning of our journey.
Okay. So I think we should start with this paragraph. There's something that Chidi has asked us to do, where he was mentioning ordering in descending order. So maybe we can do that for river. I think that's it. So we are saying people are drinking river water in Sokoto, so we confirm that. But look at the tap in home percentages in Sokoto too. So we can look at tap in home for Sokoto. Yeah. So there are majority people who have taps in home in these specific towns. And yet there are other people, there are quite a number of people who are still using river water from the river. So that's why they're saying that there are large disparities in water access. Like this often show that the wealth distribution in Sokoto is very unequal. So we can see that in the table. Now we are trying to sort the data by province name and look at the data for Amina in Amanzi, where we'll get only 3% of Amina's citizens have access to running tap water. So we can have a look at that Amina in Amanzi. Or is there a way we can filter?
You can try that feature, yeah.
Then enter. Yeah. So they're saying, what are they saying? That 3% of Amina citizens have access to running tap water in their homes. More than half of the people in Amina have taps installed in their homes, but they are not working. So, yeah. You can see that there are 56 people who have broken taps. So, there are still many gems hidden in this table. For example, which town has the highest ratio of people who have taps but have no running water? So we can try and run this. Let me just copy. So which town has the highest ratio of people who have taps but have no running water? You can see is Amina in Amanzi province. Yeah. So maybe I can write Amina. Okay. You had read up to here. The person who was reading?
Yes, sorry. I was talking, but I was muted. So I read up to, that's why I'm starting with it would be so nice to see this.
So maybe you can read here.
Okay. We can see that Amina has infrastructure.
I think just start from here so that we can relate with the table we've just seen.
Oh yeah, that's where I'm starting. We can see that Amina has infrastructure installed, but almost none of it is working. And only the capital city, Dahabu's water infrastructure works. Strangely enough, all of the politicians of the past government lived in Dahabu. So they made sure they had water. The point is, look how simple our query is now. It's like we are back at the beginning of our journey. Should I continue?
Yeah.
Okay, it would be so nice to see this data. It would be so nice to see this data, right? But because there are so many sources and so many towns, it's hard to explain this visually without some better tools. Imagine we could have a graph where we do this kind of filtering and sorting of data in the graph. Well, you will meet Dalila soon, and she will help us to build something like that. Insights. Okay, so let's sum up the data we have. A couple of weeks ago, we found some interesting insights. One, most water sources are in Maji Ndogo. Two, 43% of our people are using shared taps. 2,000 people often share one tap. 31% or 31% of our population has water infrastructure in their homes, but within that group, 45% face non-functional systems due to issues with pipes, pumps, and reservoirs. Towns like Amina, the rural parts of Amansi, and a couple of towns across Akatsi and Hawasi have have broken infrastructure. 18% of our people are using wells, of which, but within that, only 28% are clean. These are mostly in Hawassa, Kilimani, and Akatsi. Our citizens often face long wait times for water, averaging more than 120 minutes. Queues are very long on Saturdays. Queues are longer in the mornings and evenings. Wednesdays and Sundays have the shortest queues. The plan of action. We want to focus our efforts on improving the water sources that affect the most people. Most people will benefit if we improve the shared taps first. Wells are a good source of water, but many are contaminated. Fixing this will benefit a lot of people. Fixing existing infrastructure will help many people. If they have running again, they won't have to queue, thereby shortening queue shortening queue times are for other shortening queue times for other. So we can solve two problems at once. Installing taps in homes will stretch our resources too thin. So for now, if the queue times are low, we won't improve that source. Most water sources are in rural areas. We need to ensure our teams know this, as this means they will have to make these repairs up or stroke upgrades in rural areas where road conditions, supplies, and labor are harder challenges to overcome. Practical solutions. If communities are using rivers, we will dispatch trucks to those regions to provide water temporarily in the short term, while we send out crews to drill for wells, providing a more permanent solution. Sokoto is the first province we will target. If communities are pushing wells, we will install filters to purify the water. For chemically polluted wells, we can install reverse osmosis filters. And for wells with biological contamination, we can install UV filters that kill microorganisms. But we should install the reverse osmosis filters too. In the long term, we must figure out why these sources are polluted. For shared taps, in the short term, we can send additional water tankers to the busiest taps on the busiest days. We can use the queue time pivot table we made to send tankers at the busiest times. Meanwhile, we can start the work on installing extra taps where they are needed. According to the UN standards, the maximum acceptable wait time for water is 30 minutes. With this in mind, our aim is to install taps to get queue times below 30 minutes. Towns like Abelo, Abidjan, and Zuri have a lot of people using shared taps, so we will send our teams to those towns first. Number 4, shared taps with short queue times. That's less than 30 minutes. Present a logistic challenge to further reduce waiting times. The most effective solution, installing taps in homes, is resource intensive and better suited as a long-term goal. Addressing broken infrastructure offers a significant impact even with just single intervention. It is expensive to fix, but so many people can benefit from repairing one facility. For example, fixing a receiver or a pipe that multiple taps are connected to. We identify towns like Amina, Lusaka, Zuri, Jene, and rural parts of Amansi seem to be good places to start.
So, Lorraine, excuse me.
Yeah.
I wanted to find out from the rest of us, since I think we have how many slides remaining? 12 or 11?
They're about, I think, 12.
Yeah, so do we finish to the end or do we meet again tomorrow? Because it's been 2 hours and 10 minutes since we started.
I personally think we should meet tomorrow and finish up
Okay. Are we in
the
agreement?
rest of the slides. I don't know how
Yes,
we
agree.
finish up tomorrow plus the MCQ.
Okay.
For me, I also think we should do it tomorrow because some people did not finish the MCQ, so we should give them time to do so earlier. But the remaining is few. It's few. We can just conclude tomorrow and also do the MCQ.
Yeah.
Yes.
Okay then. I think thank you, Lorraine, Isaac, and Leroy, and everyone else who participated. Thank you, Nehemiah, for always being here to record the sessions for us. So we'll meet again tomorrow, same time. I think we'll just start at 8:30 since we started at 8:30 today as well. Then we can continue from slide 25. See you tomorrow.